We're going to explore current, how the electric current can create magnetic field. How the electric current can create magnetic field. It was first discovered by Hans Oersted, a Danish person. Okay, so the do now, let's start with a small thing, something you already know. You can use the prior knowledge to understand something you probably don't know. So you're going to first draw the gravitational field, and then you're going to draw the electric field, and you're going to draw the magnetic field. Alright, so first you're going to write the equation for gravitational field. You're going to write the equation for electric field. You're going to write the equation for magnetic field, and then you're going to draw. There is a point charge, and there is
a G or FG?
G. Fg is force. Okay, so this is a point mass. This is a point mass. This is what? Earth. This is a monopole. This is a monopole. Okay, and this is a charge. This is a positive charge, and this is.
That's a monopole.
A magnet.
Monopole.
Magnet with only north pole. Yes, monopole. Yeah. Alright, go ahead. Try your own. I'm gonna give you a few 1 minute, and you're gonna have to show your work, and then we'll take it from there. Raise hand as soon as you think you have the answer.
Oh wait, for the electric, protons go out, and just gotta do the magnetic.
Alright, you guys are ready?
Yeah.
I want to see your work.
So.
Okay. You can, by the way, work as a team. You can talk to each other, and you can solve problem.
There wouldn't be a proton without the electron.
Yeah.
All right. Let me see. Let me see your work. All right. So this is from this work from Albert. You try. Very good.
Wait.
And
F over Q, and then.
You don't need to know because.
C.
All right.
C
So.
circumference.
Oh, C for circumference. Okay.
Yeah, like a 2 pi.
All right. So this is from Isaac. All right. So let's go ahead. Let's dive into it. All right.
Because R means radius, I think.
Are you ready to dive into it?
Yeah.
So what
Does
is
R mean radius?
R is radius. Okay. So what is the equation for gravitational field?
F over A.
F over M, because Fg equals mg.
F over m. What is the equation for electric field?
F over K.
F over Q. Not K. K is the electric constant. A common misconception.
8.99 times 10 raised to the 9.
That's right.
Wow.
But we have to use the Q, right?
Yeah.
This is mass because it has to deal with mass. The gravitational field has to do with mass. The electric field has to do with the
Q.
charge.
Oh, I get it, because two very massive objects are attracted to each other, and F over Q also is a force of attraction.
Okay.
So they're both forces of attraction, so F over a sorting force.
Right. So this is mu current. Mu current over, he said C. So 2 pi
R.
2 pi r.
2 pi r circumference.
That's right. If the I increases,
So does
the
magnetic.
magnetic field. If the R increases,
It decreases.
the magnetic field decreases. Does that part make sense?
Yeah.
All right. So now let's go draw the what?
The
field. This is the gravitational field. Okay. Let's draw the electric field. So this is the electric field. Goes radially around,
Outward.
outward. All right. Let's draw the magnetic field. Right? But we cannot draw it.
Oh.
Because
Yeah, there would be no proton without electrons.
Because can you separate a charge?
No.
You can separate a charge. You can isolate a charge. Did we isolate the charge?
Yeah.
Yes, we isolate the charge. There are two types of charges, positive and negative. So we can isolate charge, but we can never isolate
Pole.
a magnet.
Mine.
We can never isolate a north pole from the south pole, or the south pole from the
No.
north pole. So the
They
monopole,
lose their magnetic field because there's no south pole to connect to, and thus the magnetic field.
so monopole doesn't exist. How do you spell monopole?
MONOPOLE.
Monopole
Oh, sexy.
does not
Have magnetic field.
exist. So what
It
exists?
does exist, but it doesn't have
No.
a magnetic field.
It does not exist. It does not exist. So for example, I'm gonna show you. I'm gonna pass me the magnet.
Instructor, you spelled exist wrong.
Okay, so I have a magnet. I have a north pole and I have a south pole, right?
Mm-hmm.
What if I cut it in half? Then how many north and south pole I'm gonna have?
4.
4. If I cut it like, if I keep cutting it forever, and I'm gonna left with only an atom, okay? Only an atom. I'm gonna cut it so many times. I'm gonna take a scissor and I'm gonna cut it
I
until
don't think you can cut that with a scissor.
for an example, I cannot cut it anymore and I hold it like Democritus. What would I call it? An atom. Would that atom have?
A magnetic field? No, I don't think.
Yeah, it will have magnetic field because that atom will have how many poles? 2 poles. North pole and south pole. You can never be able to separate the north pole from south pole or south pole even if you cut it. The moment you finish cutting it,
When you cut a north and south pole, new north and south poles form on the bottom.
very good. New north and south pole for, and then new north and south pole for, and then new north and so on. Does that part make sense?
Wait, I would like to sew it using
Last
my
one.
rope.
Okay, last one. I have to move on.
No, I would to please.
Yeah.
I would like to turn my work with the magnet.
Okay, that is correct. As soon as you cut it, new north and south pole created, being created. No matter how small pieces, you make, new north and south pole being
Even
created.
if you manage to use like nuclear stuff to split the atom, it would still have a north and south.
Okay, now let's go to the lesson. 1820 something happened. Alright, so the
And Oersted made
before 1820, people thought that electricity and magnetism, two separate electricity and
Magnetism.
Two separate force. This is electric force and this is magnetic force. This is electric force and this is magnetic force. Before 1820. In
The
18
only historical figure we've heard of is Hans Oersted.
Right,
So let me
1820.
guess, he's discovered something.
Yeah, 1820, Hans Oersted, a Danish guy, he was actually teaching physics. He was demonstrating what?
He was demonstrating
Wire that carries
Charge.
current. Wire can,
these alligator wires.
Yeah.
that you-
Oh.
wire you can, where is that another tape? There is another tape. I put it somewhere.
Oh, you're behind
Okay.
the black back.
So you can create lemon battery circuit, right? Then circuit carries the current, right?
Yeah.
So that means the wire carries the current, right? So now let's put the wire here. What is the direction of the wire? Is it a vertical direction?
Yeah.
Yeah, vertical direction. Okay. So and then he had a magnet over here. He had a magnet over here. Does that make sense?
Yeah.
So,
North and
do
south.
you want to put the magnets there to demonstrate or anything?
Oh yeah, magnet over here. So-
In the exact orientation? That's
Yeah.
the opposite of the exact orientation, but yeah.
So here is a magnet.
So the North Pole was
Oh,
facing.
he didn't even have a magnet.
Oh,
He did not have a magnet, he had a compass.
Oh.
Compass.
Yes. He had a compass.
For direction.
Yeah, so he had a compass.
He wasn't going home, he was teaching physics.
So he had a what? Compass.
Compass.
So as soon as
So what
As-
did he do with the
as soon as he attached the battery,
Uh-huh.
as soon as he what? He
Attach
did,
the battery.
as soon as he did attach the battery,
Wow, you are really
As-
going overboard with this stuff.
yeah, as soon as he attached the battery with it,
Mm-hmm.
what happened? What did he see?
The compass.
The compass, the needle in the compass
Down.
deflected. Before he attached the battery, what happened?
It
All
went
the electrons are sitting. All the charges are at rest.
Okay.
No deflection to the compass.
Compass.
As soon as he attached it to the battery, what
And
happened?
then attached it to the compass he did?
Was that?
No, did he attach it to the compass and then the compass changed
No.
direction?
No.
No.
He attached the battery
To the
the-
alligator wire?
to the wire, and then electron started moving. Electron moves mean electron carrying the charges, and charge moves mean there is a
Current.
current.
Oh, so
Oh.
like if you put a compass on one end of an alligator wire and then put a battery on the other end of the alligator wire, the charges from the battery would go through the wire and thus deflect the compass much like a magnet would.
That's right. And then, well, so the current moves at the north direction.
Mm-hmm.
Does that make sense?
Yeah,
And then what happened in this one?
yeah.
The compass needle
Point
Shift
north.
deflected. Okay.
deflected, so
So-
it shifts from south
So
all the way to north.
so that allowed him to create a hypothesis. What is the hypothesis he created? Current carries wire. Current
Or wire carries current.
Current carrying wire creates
Magnetic field.
magnetic field around it.
I can actually see that the fluxing right now. The pen isn't pointing south that much.
Right. Now, I mean, there is no current in this wire, right?
Yeah.
Because this is not a circuit. We can create a circuit,
We
but we
could
cannot put
create
it on
a
a flat board. We have to do it on the table.
And I don't want our online students to like freak out and not know what's going on.
Right.
So
Okay.
yeah.
So, what is the hypothesis?
Current carrying wire creates magnetic field.
Actually, but it was a big breakthrough. You already see that, right?
Mm.
The breakthrough is a wire that carries the current create magnetic field. That means current creates magnetic field. That means electricity and magnetism has a
Connection.
connection. Now,
Only 200 years ago, I'm surprised how humans have advanced so
oh yeah, he calculated only 200
years ago.
years ago.
Exactly.
Only 200 years ago. Anyway,
Nice.
now we have to find the direction, and to find the direction, we use the right hand rule. Right hand rule. Get your right hand ready.
Right hand.
Right hand rule.
Look.
Okay, right hand rules. So what do? Do you have a thumb?
Yeah.
You put your thumb at the direction of the current.
Current.
And do you have fingers?
Yeah.
How many fingers left?
4.
4. And you curl your finger.
Curl.
You curl your finger
Around.
around the wire. Okay. So if you do curl your
So
finger
when
around the
it
wire,
thumbs up, so
what do
when
you
the
see?
wire thumbs up,
What do you see?
The magnetic field.
That is the direction of the magnetic field. So this is the 2D version. Okay. So if you the thumb
what
is
the X's in the dots represent?
this is enter.
Entrance and exit?
Enter. This is enter, and this
Into the
is
board.
Exit.
out.
Exit
Exit or out.
of the board.
Out of the board. Out of the board.
So I goes up, and then it turns around clockwise, and then it goes out.
Out of the board. Okay, this is enter means why? This is inside the
Board.
inside board.
I get it. So the current
Ooh.
from the I get it. So the current, the electricity from the battery travels up, the wire end, and then it goes down, and out of the board.
Okay.
And that creates a sort of circuit.
So, oh, now you see that the radius has something to do with it, right? It creates a circular. The magnetic field is circular, right?
Yeah.
Does it make sense? It is circular, right?
Yeah.
What is
So
it?
the
It's counterclockwise, right?
So
It's circular.
The circumference
So
of that magnetic field would be very important.
2 pi r. Now you see 2 pi r has something to do with this, right?
So this is
Circular.
so pi I over the circumference of the magnetic field. So pi I over the c subtext.
Not pi I, mu I.
Mu I.
Yep.
Oops.
Okay. All right. Now let's quiet for a second and let's say it again. My thumb should be at the direction of the
Current.
and I'm gonna have to call other fingers
Uh-huh.
around the wire, and that would be the direction of the magnetic field. So it goes, my finger goes inside the board and come out. Going inside the board,
X.
the symbol is X, and coming outside the board,
Dot.
the symbol is dot. Does that part make sense?
Yeah.
All right. So now, can you paraphrase what I said?
So the torch from the battery.
You can come over here and demonstrate it.
Oh, no thanks.
No, you can.
No thanks.
No, you can.
Okay. So the torch
No.
from the battery.
At the direction of the current.
So you have to go the direction of the current.
At the direction of the current, and call your finger. Okay, this is okay. That's it. Okay. So now his thumb is at the direction of the current, and he call his finger around the wire, and that's the direction of the magnetic field. Now you come over here and demonstrate that.
Okay, over. Good luck.
So, all right, this is a student center classroom. So this is a demonstration by student. So at the direction of the current, and put, okay, and call your finger.
That doesn't look much
So-
like a student.
Okay, so this is the direction of the current,
Yeah.
and this is the direction of the
Magnetic field.
magnetic field, and we call it right hand rule. Okay, this is a student center classroom. So most of the time, the student teaches the class. All right, now what we're gonna do? We're gonna create a problem, and that is called exit slip. Does that make sense?
It's always called an exit slip.
Okay. So exit slip. Okay, exit slip. Let's say the current now, instead of from north, instead of to the north, the current moves to the
South.
to the south.
So
Current moves to the
now,
south. Current moves to the south.
so now wait, so what are we asking?
I'm gonna tell you. And how much current is inside the wire? 45. Let's say 45 amps. So I have
Probably no, less than that because the current doesn't even work, but let's just assume.
I have 45 amps of the current inside the.
10 raised to the negative 7? Maybe?
All right. Can we focus?
Okay.
I have 45 amps current inside the
Wire.
wire.
And we saw that it could differ the compass. So would it have some like magnetic field something?
We want to find the magnetic field. Very good. Good point. We want to find the magnetic field 2 centimeters away from the current carrying wire. So we're going to find them.
Do that using our equation.
Go ahead. 1 minute.
I over 2 pi.
You do it independently. This time you're not.
I have a question. What is mu?
Mu is 4 pi times 10 raised to negative 7.
Oh.
Mm.
This is interesting.
So I want you to find the magnitude of the magnetic field, and I want you to find the direction.
Alright. So 180 times 10, 180 pi times 10
1 minute.
Then over, okay, 2 pi, 4 pi. So, 1
I think I got something.
I want to check your answer.
I'm not done. I'm not done.
Okay.
So, this is equal to 25 plus 20. 45 times 10 raised to the negative 7. 4.5 times 10 raised to the negative 6.
What did you get? Where is your answer?
4.5 times 10 to the minus 3 Teslas.
And what do you got?
4.5
This
times
is-
10 raised to the negative 6 Teslas.
This is
Some-
Albert. And this is
Somehow
Oh,
got-
I say 4. I'll change it to negative 4.
Isaac. So yeah. So this is, what is it? Neo. I'm gonna use black. Neo. None of you give the direction. So you give the direction. What is the direction over here?
Oh, the
Is it cross or point?
It's gonna be.
cross.
Is it, you
I think
Oh, it's gonna be a
Point.
point.
it's point.
Because this is the opposite way, so this is the end.
It's the point. Okay, this is the direction. So direction is outward. Is it going inside the board or coming outside?
Going up.
Coming?
Up.
Coming out. So this is the direction of the magnetic field. Okay?
Yeah.
And the magnitude of the magnetic field is 2 pi r. So 4 pi times 10 raised to negative 7. Current is 45 divided by 2 pi. R is how much?
0.02.
And that would be what? What did you say? 4 times?
Oh, I know what I did wrong.
Yes. What did you say?
4.5 times 10 to the minus 4.
Times 10 to the minus 4
Tesla.
Tesla. Okay? Alright guys, I'll see you next tomorrow.